Good morning. I'm very glad to be talking about deep customized Kubernetes for machine learning in Tencent. My speech has three parts. First of all, I'd like to talk about the GaiaStack, which is the customized Kubernetes platform, and also I will talk about why we need to use the Kubernetes, and also we'll talk about the highlights of GaiaStack on the customized Kubernetes. On this picture, it is the overall platform of GaiaStack. There are five parts in total. We got these management, the infrastructure, and the monitoring system. So today we mainly talk about the core of the system. For GaiaStack, it's consisted of multiple open source components. So the stock and SaaS is the basic support, and we use the Prometheus ES and Grafana as the outer layer. And for GaiaStack, it's a very strong PaaS platform. It can support multiple GPU machine learning frameworks like Spark Cafe and PyTorch, etc. Why do we choose a custom Kubernetes? When it comes to the community version 1.6 to 1.12, which is about to be released, we keep focusing on the support of the GPU. We realize that community has always been dedicated on the extension of API, but they didn't really focus too much on special jobs, and it doesn't have certain jobs that are missing, for example, the GPU topology awareness and host device for some apps, because some trying to use some devices on the host, but they don't have the necessary support and also resource management. Currently, Kubernetes only uses the card, but actually, when GPU is running, you can also allow users to pick the the percentage of the computing resource. And also for Kubernetes, the deployments stateful set job or cron job isn't available for machine learning. Therefore, GaiaStack picks a customized Kubernetes to better support the jobs for machine learning. So let's talk about the highlights of GaiaStack. there are four of them.
第一个是提高作服感
The first one is the GPU topology awareness scheduler, GPU resource management, Tapp. It's a CRD of Kubernetes, and Galaxy, a powerful CNI plugin.
就像我前面所说的，
As I have said,
对于 GPU 来说，
for
它不像
GPU,
普通的设备，
it's not
它
like a
是
regular
具有
device.
拓扑节
It
奏的。
has
因
topology.
此，当
When
用户的程序运行在不同
the
拓扑节奏的
users'
GPU 选择上，它
applications
的使用
on
效率会有一些
are
不同。
running on
比
different
如举
topologies,
一个
there will
例
be
子，
different
当一个 APP
results.
选择在
This is an
1号 GPU 设
example.
备和
If
1号设
it's
备
a
里，
GPU
1号
0
设备
and
时间运
GPU
行的时
1,
候，
if
它的运
the
行
app
速
runs
度明
on
显要
these,
高于
it
我
runs
们
a
原
lot
先在
faster
0号设备和
than
3号设备的运行时
GPU
间。
1 and GPU 0 and GPU 3.
为了避免 GPU 拓扑节
To
奏对
avoid
程序的用
the
户的系统带来的影
topology's
响，GaiaStack 选择了
impact
系统
on
化
the
一个
performance,
GPU
GaiaStack picked a
GPU 伺服
customized
器，它的伺服
GPU
器能感知
scheduler,
GPU 的这种拓扑
and
节
it
奏，从
can
而
sense the
这样可
topology of
以
the GPU.
应用在传输数据上
By
的一
doing
些损
so,
耗，这
it
样的
can
话能提
reduce
高机器
the
学习的运行效率。
consumption or
如果不
these
展示的是
loss
我
at
其中的一个例
during
子，
running. There's
通
an
过例
example
子
here.
所表示的是，当我
In
们
this
选用两个
example,
GPU
when
用
we
运行
pick two
英伟达公司的
GPUs,
NVIDIA
it's a
程序的一个闲对比数
NVIDIA's
据。
comparison
从图
result.
中的结果可以看出
As we
，GaiaStack
can
调度器
see, the
在
GaiaStack
选择两个 GPU 设备
scheduler
为该程序运
chooses
行的时
two
候，
when it
会
chooses
给你
two
同时选择一个最
GPUs,
好的
it
0
can
号设
it
备和
would
1号设备。
pick the best
而
one,
普通
a
的
zero
普
and
通的调度
one
器，它的
as
选择的
default.
方式
And
就
for
比
the
较随
regular
机。
scheduler,
如果
the
在此
choices are
情
more
况下，它
random.
可能会给你选
In
择
this
0
case,
号设备
probably it
和
will
3号设备
pick
进行运行。
GPU 0 and
那么
GPU
在同样
3.
传输移道数据的两
Then
套数
when
据
you
4号数据、
transmit
8号
a
数据的
data
时
of
候，会
1
发现
gigabytes, 4
选择
gigabytes, and 8
号设备、1
gigabytes,
号设备它使
when you
用的时
pick
间
GPU
程序
0
传输
and
数据所用的时
GPU
间
1,
是
you
0号和3
can
号设备的
see
时间是一样
the
的。
time only for GPU 0 and 1 is only half of the time used by GPU 0 and 3. So it can flexibly perceive this GPU topology or make it faster to transmit data. When the user is using GaiaStack platform, they don't have to choose the GPU. The scheduler can automatically pick the best GPU topology at that moment. The next one is about the GPU resource management on GaiaStack. For Kubernetes, it supports multiple pods. For example, the zero point 0.1 core or zero point 0.5, so they can fully utilize the computing resource. So whether GPU can share in the same way? Yes. For NVIDIA, they have realized certain GPU sharing approaches. For example, for the VM, there's a NVIDIA grid, and there's a multiple process use MPS service. We have looked into these two approaches by NVIDIA. We have done some tests as well. We realized the approach by NVIDIA has a good official support and good software deployment, so the users can easily use the GPU sharing, but in some cases or at some extent, it is not suitable for Kubernetes platform or GaiaStack platform because of the following. For NVIDIA Grid, it is mainly for the virtual machine, but on GaiaStack platform and for some services we provide, most users choose containers based on rank, so the VM is not an appropriate approach. And for MPS service, it's mainly for the process, but based on the official documents introduction and our test, when there is a single MPS client, when there are abnormalities and withdrawal, it can affect the MPS server and client as well. So one program crashes will also lead to the downtime of other applications as well, and we don't want that. And resource limit is another reason. The NVIDIA has the latest Volta series GPU. Officially, they said it can limit a MPS client and they can use multiple computing threads, but also in the documents they said when one application started, it cannot be modified. So when there are two users, when they are using 0.3 GPU resources together, respectively, and then they only have used 0.6 of this resource. And if one user doesn't use the computing capacity, NVIDIA's hard limit will lead to such a result where the user could have fully used the computing resources. However, in reality, they can only use 0.3. So what we want is when there's nobody using it, even though the user applies for 0.3 resource, we can allow them to use the whole GPU in our case. And last one is about time slice. By NVIDIA, NVIDIA's time slice, they evenly distribute to each MPS client, but when they submit app to the setting, they can just be like a CPU. They can set 0.3 core or 0.7 core. But if you use the same approach to set NVIDIA, they will not follow what you expected. They will not give user A 0.3 or user B 0.7. Actually, it will distribute that evenly.
Therefore, based on the above analysis, and we can find that the NVIDIA shared solutions is not that perfect. So we want to design a new GPU shared solutions to support the above mentioned functions. Well, for level, this slide shows the design of our solutions. And we can find the vGPU manager is a core part of this design, and our solution has the following advantages. First, it uses a line-wide server. Well, compared with others, in the simulation scenario, we will use the API transmit mode, But when the calculation, when there is a large amount of calculation, and this data must be transferred to the central control layer, then it will lower the user experience. Well, our solution uses a lightweight server, and only limited amount of data or service will go through the servers. So the resources of each user is in the range of the available thread. While for the second, the time slice is based on request of share. Well, as I mentioned, for NVIDIA, they use a default sharing request. But when users submit such request, they have their different demand. For example, the user A use 0.3 while user B use 0.7. Well, for NVIDIA solution, they give both users with 0.5 to perform that. Well, for user B, they may not very good or they may not be happy with that result. For they pay the cost of 0.7 but only enjoy the service of 0.5. While our solution is based on the user's request, and when one of the server is downtime, and it will affect other client port or the whole server. Then, well, for the other users, they might accept such result. But our solution just avoid that issue. And the downtime of one user client may not affect the others. And when all the part runs normally, while if the user just crack down or meet failure, it only affecting limited service. But the resources of the thread can be ensured or can be guaranteed. Well, for the other part, I would say the limits can be changed at any time. For both users, if they request 0.3 user resources, while the rest 0.4 will be available. Well, maybe at the peak time, the users may allow to use the rest of 0.4 services so that the calculation of the GPU can give a full play and the calculation capacity will not be limited. Well, last but not least, we have the zero injection to users' application. And we use a framework, and the user's mirror framework can be used on our GaiaStack and without any modification or changes. And this is experimental results to improve that our time slice is better than NVIDIA's solution. And we run this data on Tesla P4 server, and we use two different applications. One uses 0.3 GPU and the other uses 0.7 GPU. And as you can see on the slide, the app with 0.3 GPU runs first, and we can see that the default time slice for NVIDIA is actually quite even to both applications, and we found that the task using 0.3 GPU will finish first. But our strategy is divided the available thread based on the request of share. And for the service with 0.3 GPU has lower time slice than the other that with 0.7 GPU. But the server with 0.7 GPU will perform earlier than the server with 0.3 GPU. So our strategy is divided based on the request of share, and the large share will finish first. And when the task that using 0.7 GPU is completed, that means this part is available. Then the task with 0.3 GPU can use such part. Well, next I will introduce the Tapp. This is our customized CRD. It has similarities with stateful set, but in some certain scenarios, Tapp have more functions than stateful set. For example, stateful set does not support the frequent store to reboot, upgrade, downgrade on a specific port, but our Tapp can perform the repeated operations of any port, including deletion, stop, reboot, rolling upgrade, and downgrade. Well, for the stateful sets, they must manage the different port at the same time, but our solution can manage different versions of port while with the same Tapp. That we can see we support different versions of port to running in the same Tapp. For the other part, the change of versions may be reflected into the changes of mirrors. Well, we can change the image version of a port so that the testers can test new functions while not stop the existing functions. And when they found that such kind of port meet the requirements, so they can mass produce such kind of ports. Well, now I will introduce a Galaxy, the powerful CNI plugin. It can not only support internal network but also support the external customers' private or public cloud. So for a network, I believe Galaxy is quite necessary, and so that we developed it to support different use of customers. It has the following advantages. First, it both supports underlay and overlay technologies, and second, it adapts to any network scenarios. And for the third, it has good performance. We can see good network performance. Well, for the fourth, it has a zero injection to client network. If the client deploys a Galaxy network, they will not change the topology. Since our Galaxy can adapt to the client network and will not make any changes to client network. Once you chosen the Galaxy plugin, and you can choose appropriate network mode according to your need. For example, if you're quite sensitive to latency, and then you can see the enclave network. If you're not sensitive to latency, then you can choose overlay solutions. Or the different app can choose different network mode, and the pod on the same host will not affect the other, not affect each other, no matter you're choosing underlay or overlay solution. We're talking about the CNI plugin. I guess you are quite interested in its performance. So I will introduce the performance. First is overlay performance. As you can see on this slide, this is a result comparison of running Galaxy on Flannel. While Galaxy's overlay solution chose IP plus host gateway, while the other chose VXLAN, that is a Flannel mode. But as we can see on the slide, the performance for our overlay solution is 40% better than the Flannel. That is to say, the mixed solution is better than the single Flannel solution. And we also offer the recommendation to Flannel communication, and our solution is finally accepted by Flannel community. And this is my introduction, and if you have more interesting questions, welcome. Okay, please use the microphone. Oh my gosh. Please use a microphone. Okay, I'll repeat the question. He mentioned for the community, if they have the new patch which supports the VGPU support, so what is the differences between our solution and the other? For the second question, that I only mentioned the computing resources. Well, how do we select these different resources? Well, for the first question, I haven't browsed the other patches, but I guess that these patches are proposed by NVIDIA. They want to promote their solutions. Since they support the virtual immersion. So I believe if you choose a NVIDIA solution and the users need to buy the NVIDIA technologies to use such virtualized solution. Well, for the second question, for the storage selection, I believe for the storage of GPU is quite sensitive to users. Well, he mentioned if we perform or use X resources on time A, but what should I do if I want to use resource Y on time B? And once your resources volume is increased, but the other users remain their request. If we do not have additional resources, then you cannot rob the resources from other users. For NVIDIA solutions, they do not allow such actions, and they will not stop users' action and perform the others. So for other solutions, we use the hard limit. But if the machine has available resources or is only used by a single user, then we will avoid such excessive resources, but the users must afford such risks. Once other users increase such service, such excessive resources must be stopped. Well, any other questions? No, please use a microphone.
Let me repeat his question. When it comes to OCR machine learning, we use the Ceph as the base layer storage, and it will read a lot of small documents. So when Ceph is reading the files, there will be performance damage, so it might not be better than the local storage. So if Ceph has any advantages or anything special about it? So that's the question. And our Ceph is maintained by a dedicated team. And in Tencent, we have OCR project. We would actually do some optimization, which will support the high IOPS file storage. So it will be a big improvement comparing to the default of the community. So when they read a large number of small files, the performance will not drop dramatically, and the Tencent Cloud will also use our technology. So the next question is about the first picture, about the selection of GPU. And the microphone of this room has problems, so they only have one mic, and the speaker will repeat the question. First of all, about the connection of GPUs, the perceptions are the connections of GPUs are connected by NVIDIA. They will tell you how they are connected, and also for each type of connection, they will tell you the performance as well. By using the drive of NVIDIA, you will know the GPU is displayed in what type of topology. At this moment, when the user pick GPU, it will tell you how many cards you're going to use. And just as the example shows, if you use 4 cards, it probably is a complete digital, but if I remove 2 on the left and keep the 1 on the right, if you want to use 3 GPUs, probably you will use the branches on the left. The slower speed will be 2 PCI switch. Then it will be the slow one for the transmission. But on the right-hand side, if there's another layer for PCI switch, you can also pick 3 GPU applications on this one. But because there are 3 layers of PCI switch, the average transmission data will be limited. So actually, our scheduler considers the number of layers for the PCI switch. So by doing so, it helps the user to select a better way of transmitting data. So they will not have the small sequence speed because of insufficient bandwidth. The next question. The performance, we have compared the performance as well. Actually, this card is distributed to this VM, and then it cannot be distributed to the others. So in our scheme, we realize the sharing, and it is a lightweight server, so not all GPU commands will go through our server. We only select certain GPU commands. We actually released a paper on the related technologies, which will be released in October, which was released in October or something. It was a quite detailed introduction. I can send you the link of that paper so you can take a look and see how we realized our thread limit and time slice. Well, if the user selects 0.3 and 0.7, this will distribute time to different users. I forgot to repeat the previous question though, but for this question, it says when GPU is integrated on the Ceph, how big is the scale of the Ceph? as far as I know, our company supports almost all machine learning jobs. So roughly there will be 15 PB of data. And when there's a time delay, I don't have the specific data on my slide deck. We have a dedicated team which has done very detailed comparison testing. So if you're interested, I can send you the data from the testing, from the comparison test. Next question. You talked about, or the speaker will repeat the question. So the question is, for the Tapp and Ceph, it seems that they are not too different. So the question is, why is more suitable for machine learning? Actually, it's related to our business as well. For many users, when they submit one app, they rarely stop this app and start another one. So they feel this way of testing is very troublesome. For example, for the current machine learning service is already deployed online, and then if the user wants to test when they have a new model, if they want to see what's the prediction of this new model. So for Ceph, if you want to do such a test as described, you've got to do rolling update, and when you start the rolling update, all the running containers will be updated to the latest version. But in this case, if you realize the model is not good as expected, the user might realize there are some changes, and then they will feel why suddenly there's a change. But developers don't want users to feel such a change. So in this case, you can use the Tapp, you can use the image, change the image of a few parts and update it to the testing version, and then it can connect the testing version and the ordinary version. So some of the users can be testing the new version, while some of the users can use the older version. It makes it easy for management. Once you discovered that the test model is not good, you can actually switch the testing version back to the original version for continuous service provision. Last question, please. Let me repeat his question. So for the community, it's plugin. They use a plugin to support the NVIDIA's GPU, but it seems that NVIDIA don't have enough inputs in it, so they only distribute on card. And for us, we provide the GPU sharing. So his question is it possible that we would actually open this management model? I might not be able to answer to you correctly, but based on our perception, open perception, if we feel it's appropriate, we will make it open source. We also issued an essay on this technology. So if you're interested, we can send you the paper for the conference. I'll tell you when the paper is going to be released. Because the paper is already selected by the meeting, so it is only a matter of when it's released. Thank you very much for your listening to today's speech, and that's the end of it. Thank you.